Hello, this is the part 4 of the video lecture series on solving triangles. Today, we are going to look at angle of elevation and depression. So, what do we mean by angle of elevation? The angle of elevation is basically the upward angle between the line of sight of an observer and a point of interest or an object of interest. For example, if you have an observer here, let's say there's someone standing here, and the person is trying to look at something above his or her high level. So if this is a high level, and this is the line of sight of the observer. So the person is looking at that object somewhere here, above the level of his or her eye. Then the angle which the line of sight and the eye level. This is the normal eye level, and this is the line of sight. The angle between the line of sight and the horizontal level, which is the normal eye level, the upward angle is called the angle of elevation. So let's say it's looking at this. So that angle here is called the angle of elevation. So theta is known as angle of elevation. So why is it an angle of elevation? It's because it's looking at something that is above the normal level of the eye. So, but if the observer is looking at something that is below the normal level of the eye, then the observer is going to look at that object with an angle of depression. So if that is angle of elevation, let's look at the case where the observer is looking at something that is below the eye level. Then let's say you have somebody here. This is the normal high level, and it's looking at something that is here. So this is the line of sight of the observer, looking at that thing here, and this is a normal high level. So this angle between the normal eye level, and the line of sight is known as angle of depression. So this time, theta is called the angle of depression. Why? Because the object of interest is below the normal level of the eye. So this is object of interest. So what you are looking at, what I mean by the object of interest. So here, this is object of interest. Object of interest. Okay, so that's basically the definition of angle of elevation and angle of depression. So there's a relationship, there's a kind of relationship between angle of elevation and angle of depression. So let's say you are here, and this is the normal eye level, and something is being looked at with an angle of depression. Let's say this is the ground level, or maybe this is a particular reference that we are looking at. So if you look at something with an angle of depression that is equal to theta, so this is the normal eye level. So if you are here, you know, this you are looking at this thing here. Okay, so if we switch around and your object of interest is now here, and your eye is now here, then you look at that object with an angle of elevation that is equal to theta. So if your eye level is here and your object of interest is here, this is the angle of elevation. But if the object of interest is here and your eye level is here, then you look at that with an angle of depression that's equal to theta. So if you look at this, theta, if I call this, then let me use theta for both. If I use for angle of depression, I use alpha. And for angle of elevation, I use alpha, and angle of depression, I use theta. Alpha will be equal to theta in this case. Why? Because they are alternate angles. So, by alternate angles, because these two lines will be parallel. So when you have two parallel lines and you have a line that goes across like that, so this line is called a transversal in this case. So the angle of this angle here will be equal to this angle here. So in this case, the angle of elevation, which is alpha, is equal to the angle of depression, which is theta, because they are alternate angles. Okay, so that's something you need to keep in mind. Now let's take some examples. See how this works. Example 1. From a point on the ground, 12 feet from the base of a flagpole, the angle of elevation of the top of the pole, is 53 degrees. How tall is the flagpole? So how do we solve this? So we have to first draw a diagram to represent that. So we construct the triangle that we are going to obtain when we represent this problem in the form of a figure. So let's say this is a flagpole. So here's the flagpole. And from a point on the ground, 12 feet, this is the ground level. So from a point that is 12 feet from the base of the flagpole, this is the base of the flagpole, this is the top of the flagpole, T, let me call the top T and the base B. So from a point, let's call that point P. And between the base and the point is 12 feet from the problem. So the angle of elevation of the top of the pole, the angle at which you look at the top from this point P, is 53 degrees. So the question is, find how tall is the flagpole. So you are looking for TB, and you have BP. So, and you have an angle. So in this case, we don't have the hypotenuse. So you have the opposite. You are looking for the opposite, sorry, but you have the adjacent. So we are looking for opposite, we have the adjacent, so that we definitely use tangent. So tan of the angle, tan 53 degrees, will be equal to opposite, which is TB or BT divided by BP. So tan 53 degrees will be, what is BT? That's what we are looking for, divided by what is BP, 12. So we cross multiply, then BT will be equal to 12 tan 53 degrees. And that will give us 12 multiplied by, okay, tan 53 will give you 1.327. So 12 times 1.327. So we multiply that by 12, then you have 15.92 feet. So that is the height of the flagpole. Okay, that's very easy. That's easy enough to understand. Let's look at another example. So example 2. From a plane flying due east at 265 meters above the sea level, the angle of depression of two ships sailing due east are 35 degrees and 25 degrees. So how far apart are the ships? So this question is a little bit complicated, but let's see how to solve it. So you're told that from a plane that is flying due east at 265 meters above the sea level. So the plane is flying due east, that's towards the right. So let's say the plane is here, and okay. So there's a plane, and you have the height above the sea level as 265 meters. Then the angle of depression of two ships sailing due east are 35 degrees and 25 degrees. Then you have two ships, so that are sailing on the ground level due east, like that. The angle at which you look at them will be 25 degrees. So the angle of depression will be the angle 25 degrees for the first. So let's say the first ship is here, and the second ship, the angle of depression is 35 degrees. So that, so that one, sorry, 35 degrees here. So which means this angle here is 10 degrees, this angle. I don't think that's important. So this is ship 1, if I call that A, and if I call this B, so this is the base, let's say this is the plane, P is directly below the plane, let's call that C, for example. Now, the question is, how far apart are the ships? So you're looking for this distance here, AB. So before you can get that, we need to first calculate this distance AC, because AB that we want to look for is basically AC. If we get AC and you subtract that from, if we get AC and you subtract BC from it, we should be able to get AB. So from here to here, and you take away from here to here, that should give us from here to here. So how do we get AC? So what we need to get now is AC and BC. Now, because we know that this angle must be right angle, so the normal eye level and that, this must be 90 degrees. So it means that, and from here to the second ship is 35. So this angle has to be 90 minus 35. So this angle here has to be 90 minus 35, and that will be 55 degrees. So this has to be 55 degrees. So if I know that, because I know the height above the sea level where the plane is, which is 265, I can use that to calculate BC. Now I'm consider triangle BBC. So I'm looking at this triangle here. So I want to get BC, which is opposite to this angle. So I know I don't have information about the hypotenuse. So I know the adjacent to this angle, and I'm looking for the opposite. So that's tan again. So tan 55 degrees will be opposite, which is BC divided by the adjacent, which is 265. Now, if I cross multiply, BC will be 265 tan 55 degrees. And that will give you 265 multiplied by tan 55 degrees. So that should give you 378. 378 meters. Yes. You see. So if you press tan 55 degrees in your calculator and you multiply that by 265, that gives you BC. Now, I want to manage this space here. Then I can calculate AC. How do I get AC? So calculate AC, I'm going to use triangle A or PAC. Consider triangle PAC. So if I use triangle PAC, then this angle here, so let's say this is a triangle. So PAC. This angle here is no longer 35, but what? Because this small angle here is 10, then if you add that 10 with this 55, that gives us the angle that we need, 65. So that angle has to be 65 degrees. Because now I'm looking at this triangle. So this line is what I'm considering. This, and this. So because this is 55, and this is 25, and this is 35, it means that this small angle here will be the difference, which is 10 degrees. So we add 10 to 55, we get 65. Now I'm looking at this angle, this triangle. I have 65 degrees as the angle. I'm looking for AC, and I have 265. So if I use tan again, tan 65 will be opposite AC divided by adjacent 265. So AC will be 265 tan 65 degrees. So that will give you 265 multiplied by tan 65. So 568. So that will give you 568.3 meters. So now the difference between or how far apart the two ships are will be AB, as we've written here. So we can calculate that because I know AC now. So AB will be 568.3 minus 378, which is BC. And that will give us what? 378. 190.2. 190.2 meters. So that is the distance between the two shapes. I hope that is clear enough. So now let's look at one more example quickly. Example 3. A surveyor measures the angle of elevation of the top of a perpendicular building building as 19 degrees. He moves 120 meters nearer the building and finds the angle of elevation is now 47 degrees. So determine the height of the building. So I need to manage the space here. So what do we do? So let's say this is the vertical building, and let me call the base B and the top T. So the surveyor measures that the angle of elevation of the top of the building is 19 degrees. So let's say from a point, let's say the surveyor is here and measures this angle of 19 degrees. And when he moves 120 meters nearer, so he moves close to the building, so 120 meters, and he measures that the angle of elevation is now 47, so it has increased. So the question is, determine the height of the building, h. So you want to get h. Now, how do we solve these? Well, for us to get h, we need, so let me label this to make it easy. Let's call this A and call this C. So if I want to get the height, I need BC. So I don't have BC. So let me call BC X. So if I consider triangle, let me manage the space. Consider triangle TBC, tan 47 degrees, because opposites and adjacent. So I have no information about the hypotenuse. Will be opposites h all over adjacent x. So if we cross multiply, then h will be x tan 47 degrees. So I can keep this one as equation 1. Then if I consider triangle AT or ATB, AT and B, then which is the bigger one, then tan 19 degrees will be opposite h over, in this case, the adjacent will be x plus 120, because that will be from here to here. So you have to add x and 120 degrees. So if I cross multiply, h will be x plus 120 tan 19 degrees. So because, let me call this equation 2. Equation 1, h, they are both h, I can equate them together. So I can say x tan 47 degrees equals x plus 120 tan 19 degrees. So what is tan 47 degrees? Tan 47 degrees is 1.07. Then we have x multiplied by 1.072. That will be equal to x plus 120 multiplied by tan 19. Tan 19 will be 0.344. 0.344. So if I remove this bracket, so this will give me 0.344 344x plus 120. This will give me 41.32. 41.32. So this will give me 1.072x. So if I collect like tens, I will have 1.072 minus 0.349. So 1.072x minus 0.349x equals 41.32. So if you subtract this from this, you have 0.723x equals 41.32. So 0.723x equals 41.32. So then move to the next page, 0.723x, 41.32. And divide both sides by 0.723, 0.723. Then x will be 1.32, 57.1, 57.15 meters. So that is x. So we go back, then we are out to determine the height of the building. So h. So I can use any of the equations. H equals x tan 47. H equals x tan 47. So h equals x tan 47 degrees. So I have x now, I can calculate h. H will be 57.15 tan 47 degrees. So h will be 57.15 multiplied by tan 47 degrees. The tan 47. So h will be 61.3 meters. So that's the height of the building. I hope that is clear enough. So we'll stop there and I will see you in the next video.